Assalamualaikum and hello everyone. Today we are from Group 6 would like to present to you about the ultrafiltration process in water treatment and its relationship with the mass and energy balance.
These are our group members.
As we know, clean water is one of the most important resources for human health. However, raw water from lakes, rivers and other sources often contain suspended solids, bacteria, virus and other contaminants that must be removed before the water can be safely used. So, how can we overcome this problem? So, one of the technologies widely used in modern water treatment is ultrafiltration. So, what is the ultrafiltration? Ultrafiltration is a membrane separation process that uses a semi-permeable membrane with very small pores to remove unwanted particles from water. The membrane allows clean water to pass through while retaining larger contaminants such as suspended solids, microorganisms and colloidal particles. During filtration mode, feed water enters the membrane module, where clean water known as permeate passes through the membrane pores while contaminants are retained. Over time, these contaminants accumulate on the membrane surface and reduce its performance. Therefore, a backwash and air scoring process is carried out to remove the accumulated particles and restore the membrane efficiency, ensuring a continuous supply of clean and safe water.
So, this is an overview of the chart for process ultrafiltration in process water treatment. So, for the flowchart of ultrafiltration in water treatment, first process is the process feed, which is the raw water into the process tank. And in the process tank, we have to filter the larger particle by process the coagulation and also anti-scaling. Which is we can put the chemical compound as a potassium manganate, also aluminum sulfate as a coagulant, and also calcium carbonate anti-scaling. The second step is which is the pressure deliver, which is we have a pump. The function of the pump, which is we drive the water through the control valve directly into the ultrafiltration modules, and the function of pressure also is to suck the water through the membrane. So for the third flow in ultrafiltration process water treatment, which is we in the membrane separation, which is the contaminant have a stop on the membrane, and from that the membrane separation can filter out the bacteria, virus and other microorganisms. The membrane also can plug and get the filter of the small particle in the membrane. And lastly we have a water collection and also rejection. The other name we call it the concentrate and permeate. The clean water be split into the permeate stream, and after that permeate stream being disinfection and storage the treated water. And for the rejection water, we call it is split into the stream concentrate. So in ultrafiltration process, we have 14 that we can evaluate the process. The first is the transmembrane pressure. We call it TMP. TMP is we call it heart rate of the system. If the TMP spike up, it tells us the membrane pore are clogging and need a backwash. The second is we can evaluate by permeate flux. Permeate flux is like speedometer. It measures how many liters of the clean water pass through each square meter of the membrane per hour. And the third is recovery rate, which is the efficiency yield. We want to see the 90% until 95% of feed water turning into the clean permeate, not going to waste. And lastly, for the LRV, or we call it loss reduction value. Loss reduction value is quantified by the joint removal. The standard target of LRV is 4, which is 99.99% of bacteria and viruses are physically blocked. So that's 14 that we can evaluate in the ultrafiltration process in water treatment.
Problems and numeracy evaluation. One of the main problems is ultrafiltration water treatment is membrane fouling. Membrane fouling happens when particles, microorganisms and organic matter accumulate on the membrane surface and block its pores. As the fouling layer becomes thicker, water flow through the membrane is restricted. When fouling occurs, membrane pores become blocked, water flow rate will decrease, more pressure is needed to push water through the membrane, energy consumption increase, cleaning frequency will also increase, operating costs become higher and membrane lifespan becomes shorter. This leads to several negative impacts. First, the water recovery rate decreased. Before fouling, the system produced 900 liters of clean water from 1000 liters of feed water, giving a recovery rate of 90%. After fouling, the permeate flow dropped to 750 liters per hour, reducing the recovery rate to 75%. This represents a 15% reduction in water recovery. Second, fouling increased energy consumption. To maintain water production, the pump must operate at a higher pressure. As a result, energy usage increased from 32 kilowatts per hour per day to 48 kilowatts hours per day, which is a 50% increase. Finally, fouling also causes water loss through the reject stream. Out of 1000 liters of feed water, 150 liters are discharged as reject water, which means 50% of the feed water is wasted.
From an Islamic perspective, ultrafiltration supports the principle of avoiding waste or israf by improving water treatment efficiency. Islam also teaches humans to act as Khalifa or stewards of the earth. Therefore, technologies that help protect water's resources and provide clean water for communities are consistent with Islamic values of sustainability and responsibility. Several improvements can enhance the ultrafiltration process. Anti-fouling membranes can reduce blockage and improve efficiency, while renewable energy such as solar power can lower energy consumption. Next, regular maintenance helps extend membrane lifespan, while reject water can be reused for non-drinking purposes to minimize water wastage.